Shut up and sit down.
Hey everybody, welcome to another episode of Electrician Live, Master the NEC, where we talk and learn the National Electrical Code and all things electrically related. My name is Paul Abernathy and I'm your host, and today we're going to talk a little bit about Unit 2 of our residential program. And it's a pretty important unit because it starts to talk about things like specifications and plans and all those important things that you need to know about. Now, not every residential project is going to have drawings. And a lot of times only commercial drawings will have very detailed electrical drawings, but residential, there's many occasions where there's a subdivision plan where a large contractor, electrical contractor does a lot of subdivision work, and they will actually have drawings that are very detailed. So you need to learn how to understand them, how to read them, how to move through them, and all of those things are critically important. So Unit 2 of our residential program is really dedicated to teaching things like that, and as well as other things like outlets and stuff like that. So let's kind of look at the program a little bit. Again, so Chapter 2 in our residential program is dealing with specifications. And it is, again, something that we want to be ready to jump right in and learn all these things. So let's go on and switch over to it. And so here you see Chapter 2. Now this is our residential program, and we're going to talk specifications, electrical symbols, and outlets today. Now, what are the objectives of Unit 2 in this residential program? It's after studying this unit in our residential program that's available on electricalcodeacademy.com or masterthenec.com. It's for you journeymans, apprentices, vocational students, or even electrical contractors who want to get all of their staff on board to make sure that they're very efficient and that they're all doing things code compliant as well as to the basic standards that are acceptable to the industry. And that's what this program is all about. Now, again, after studying this chapter, you'll be able to understand the role of specifications, plans, and different notations that are made on those drawings or plans. Okay, so you'll kind of learn what they mean, whether you get a set that already has information on it, or you start to add things yourself as an ad build. You kind of can do things in a consistent fashion so that everybody understands that might come into the job or other people on the job. And real consistency is real important. Now, you'll also be able to identify and explain electrical outlet symbols used on the plans for single-family dwellings, receptacle outlets, lighting outlets, switching devices or switching outlets. You'll be able to understand what a device is and how they work together in like receptacle outlets, which is the outlet is what you place the receptacle device into. All those type of things are kind of dabble in that. You also will have a discussion of those boxes, outlet boxes, and different ones like for luminaires and switches and all those type of things. And we'll even explain the mounting of the various electrical devices used in a residence. Okay, so receptacles again in receptacle outlets, and the difference, receptacle is a device, but it goes in an outlet box. So we'll cover all those details. We'll understand the preferred way to position receptacles in walls, and that's more or less dealing with if you have walls that have a certain fire rating on them, things like that. We'll understand the issues that are involved in remodeling work and try to get a better understanding of what you might run into if you're doing some type of remodeling in this chapter. We'll also understand how to determine the maximum number of conductors that are permitted in a given box. This is what we refer to as box fill, and that's going to be in Article 314. So we're going to kind of dabble in that a little bit in this unit. And then we're going to understand the concepts of fire-resistant ratings of walls and ceilings, whether it's a 2-hour rating, 1-hour rating, and those type of things. Now, talk a little bit about plans, drawings. Now, as a residential guy, we don't always get the luxury of a very detailed set of plans. Okay, sometimes it's just the layout of the actual dwelling, and then we'll mark it up and put our receptacles and show our home runs and all that. But on a rare occasion, you will get plans from engineers or designers that actually will show you where to put everything. Now, that's usually a commercial thing. It's not usually the norm with residential. But again, I've been involved with some contractors who do a lot of homes in a big subdivision, and they have specific floor plans. And those floor plans are laid out a specific way that shows where they want every receptacle installed so that they're more or less cookie cutter. And again, if you're the electrician working for that company, you need to understand what these symbols mean. Now, this is also a really good transition. As you learn all of the residential symbols, a lot of those will carry over into the commercial world as well, okay? So again, it's a good lesson to be learned here in this unit. Now, we'll show you the necessary instructions and details needed by the skilled worker who are to build the structure. We'll look at the sizes, quantities, locations of material, construction features, and all of those things on the drawings will be shown, again, certain heights above a finished floor, for example, where you might have to install an outlet box. All those type of things become real important if they're on the drawings. Okay, so we'll kind of cover that. Now, if you're doing something where you just have a blank canvas and you're the electrician that's laying it out, it's really important that you understand all of the nuances, because you might need to look at the architectural drawings. You might even have to look at the building drawings, because you need to see what height you put your receptacles are on a countertop. So what's it above the finished floor? Or maybe you have luminaires outside on the side of the dwelling, and you need to know what height to do them at. And all these things are going to be covered in the architectural drawings page or the building construction page. So you want to be familiar. It's not just the residential electrical pages that we're worried about. Now, as an electrician, I've laid out a mini house, and all I had was the layout of the house. The owners want to know where you're going to put things, unless, of course, you're doing what we call a spec home. And that means you're just simply laying out the receptacles and everything to specification. And that'd be 6-foot, 10-foot rules that we see in 210.52 of the National Electrical Code. And then you're just putting them at a point so that no point along a wall line is more than 6 feet from a receptacle. Okay, so all these type of things are part of the design, and whether or not they're already on the drawings or you have to put them on there, again, there's things that you need to understand. Now, the specifications you might get for different boxes or wiring methods or whatnot, okay, they provide information to all the trades, and every trade is going to have some type of specification. And so, again, if it's a commercial job, specifications are critically important. But when you're dealing with a residential project, they also can be important, because they might say on the specification what boxes they want you to use, what manufacturer they want you to use. They might tell you whether you can only use a metal box here or you can use a non-metallic box here, what types of wiring methods, what types of fittings, what breakers from the manufacturers they want for their panels, or they might just leave it up to you. But it's important that you understand specifications. And any time you'll have the drawings, which are the plans, blueprints, and then you have specifications for specific products maybe. Always remember that the specification is going to take preference over the drawing. The drawing is just if you're lucky enough to get a laid out drawing that tells you exactly where to put everything, at that point, you follow that. But if there's any conflict between something on the plans and something in the specifications of a product listing, you want to go with the specifications, okay? Always takes precedent over the plans. Now, you want to work with the designers, you want to work with the owners, the engineers, if you have an engineer. Most residential projects do not. Now, there's a reason, though, why we talk about this specification. Because you might not be doing something as simple as a single-family dwelling. You might be doing something like single individual dwelling units inside of a multi-family dwelling. And, of course, you're going to wire that individual dwelling unit just like a single-family residential project. But the difference is it's a larger scope, and usually you're going to have drawings and you're going to have specifications for certain things. So you want to be sure that you are fluid when you're learning the residential. It's not just about 1-2 family or one single family. Again, you could be doing multifamily individual dwelling units that are going to have residential requirements as well. Okay. Now, when we learn about electrical symbols, you're going to learn about devices, outlets, receptacles. You're going to learn about receptacle outlets, all those type of things. For example, as you see on the screen, what is a device? It's a unit of electrical system that carries or controls electrical energy as its primary function. An example of a device, let's say it's a single pole toggle switch. Now, let's say that the toggle illuminates when power is brought to that device. Well, just because the toggle lights up doesn't mean that's its primary function. The primary function of that switch is to control the actual electrical energy. So it would fall under being a device. You get to ignore the incidental illumination by the toggle switch. Okay. Now, a receptacle, for example, is a device, but that is a device or a unit that actually carries electrical energy. And of course, it's a point where we can plug in a lamp, or we can plug in a TV, a radio, or what have you, in order to get power from the electrical system. That is also a device. Now, the next one we see is an outlet. What's an outlet? Well, it's the point on a wiring system at which current is taken to supply utilization equipment. Now, don't get confused with the term outlet being something like a receptacle. Now, we've called it that. We've used that kind of trade slang. But the reality is anything that's hardwired from a junction box could be considered an outlet, because I'm coming from that outlet, which is a point on the electrical system where the wiring system is supplying utilization equipment. Now, in that outlet, you could install a receptacle, right? Or you could have an outlet in the ceiling that a luminaire mounts to. That's different, because that is still an outlet, but when you put a luminaire on it, now it becomes a lighting outlet, okay? So the outlet is the point where we're taking that electrical energy from, okay? Now, again, in an outlet, we could put receptacles, we could put switches, we could put luminaires in it. The fact of the matter is, it's the point where we're taking that electrical energy from, okay? Then you got the term receptacle. Receptacle is a contact device installed at the outlet for the connection of an attachment plug. So the receptacle itself, whether it's a simplex single or a duplex, whereas a single strap or yoke with two separate receptacles on it, which we refer to as a duplex receptacle, which is really two receptacles. That's a point where we would plug an attachment plug, you know, the plugs with the little prongs on it, into the receptacle. So that is a contact device, and it can go inside of an outlet box. I think you're getting how these are all tying together. Then you have what's called a receptacle outlet, and it's an outlet where one or more receptacles are to be installed. So if I have an outlet, just say a 4-inch by 4-inch square box, and I'm going to mount a receptacle outlet in it, that's what I'm doing. It's a receptacle mounting in an outlet. Together, it's called a receptacle outlet. Lighting outlet, as we just discussed. It's an outlet intended for the direct connection of a lamp holder or a luminaire. Now, an example of a lamp holder might be a keyless or a porcelain fixture where the lamp, or many people refer to as a light bulb, screws into it through the screw shell. Okay, that's an example of an open lamp or open bulb. Is called a lamp holder. But now a luminaire is a collection of all of the components that make up what we used to call a lighting fixture. But now we refer to that as a complete package. It's called a luminaire. Now, we have things called split-wired receptacles, which is electrical jargon. It's not official NEC definition, and we cover this in our unit. That might be where we take a receptacle and we break tabs. You have opening, which is a generic term that includes lighting outlets, receptacle outlets, junction boxes, and other enclosures. Somebody might say, how many openings do you have? Okay. And might be utilized when we're doing estimating, for example, when we're doing a takeoff. So electrical symbol here, you see the receptacle outlet, and obviously a receptacle would mount in this. And of course, as you see here, as we'll look at it from the top doing clockwise around, it says, you see the white, and it says is one of the rules that allows not less than 6 inches of conductor measured as it emerges from the cable or raceway into at the end of the cable as it comes into the box. And you have to make sure that you have at least 6 inches of conductor. Now, we'll go over this when we get into the program so that you know what code references there are to maintain at least 6 inches of conductor. Okay. Now, as you see here also, the box says allow not less than 3 inches of conductor measured from the front edge of the opening to the end of the conductor where the opening is less than 8 inches in any direction. Okay, so you have 6 inches of conductor as it enters the box, but where the box itself, like you see here, a receptacle outlet, whereas this opening is less than 8 inches in any direction. So again, a 2 by 4 inch box or 2 1/4 by 4 inch box is less than 8 inches. We have to make sure that, one, I have 6 inches, but two, I have to make sure I have at least 3 inches extending from the front edge of the box. Now, why is this? So that we have enough room to remove that device and make connections to it. Now, we're just touching the surface here. In our program, we will go into in-depth code references for you. So we wanted to be able to show you that we're going to talk in layman terms, and then we can codify it as we move through the program, okay? Now, luminaires and outlets. So luminaires are a complete lighting unit, as I said. It has the light source, such as the lamps or a lamp or multiple lamps, which we've referred to in many cases as light bulbs. But it's really a lamp, and you could have multiple lamps. Now, parts designed to position the light source. Okay, so inside of it, depending on how it's made, in order to be able to control the positioning of that lamp. And then it says connected light source to the power supply. So it has some type of internal wiring that connect up to the lighting outlet, which again is an outlet that you're mounting this luminaire onto. So a luminaire has all of those pieces involved in it. The lighting outlet locations determined by the amount and type of illumination required. So again, how many lighting outlets you need in a dwelling is going to be very indicative of how much light you need. You might want additional recessed lights, which are luminaires. And so you might add additional ones depending on how much illumination your client wants or whatever on the drawings, okay? Now, dealing with outlet devices and junction boxes. You just heard I was talking about the amount of conductor, but now we get into things like 314, which is giving you detailed applications of things like box fill and all of those rules that you need to be intimate with as you're starting to learn residential wiring. Now, you're going to serve you very well when you start moving into commercial as well. But again, starting that fundamental, you really want to grab a hold of it here in this first part of this residential wiring program. Now, it says NEC Article 314 contain much detail on outlets boxes, pull boxes, junction boxes, and conduit bodies. Again, all of that's going to be covered in 314.16 as well. That gives you the dimensions and the cubic inch for the box fill for conductors. All of that's covered in this program. We just want to kind of give you the 30,000 foot view of what to expect in the program. 300.11 and 314.23 boxes must be securely mounted and fastened in place. NEC 300.15 states where the electrical boxes must be used. And Article 314 continues with many more specific details about installations and the use of electrical boxes. So in our program, we're going to get very detailed about securing them and how to mount them, okay? We're even going to talk about applications of mounting these above suspended ceilings and how you would secure things like the cable assemblies as well. So all of that's going to be covered in the program. We'll also have explanation of these devices. Now, this right here is a device, and it incidentally is also a receptacle. So you have the female portion, and then you have the male portion. The female portion is the part that would mount in the lighting outlet or the fan box. And then you have the male portion, which is going to mount onto the heavy luminaire or the heavy ceiling fan. And they will literally mate together very much the same way as an attachment plug goes into a receptacle device. Okay, very similar. As you see here in the picture, the different rings will correspond with the different metal points that intimately connect together. And is why we had to change the definition of receptacle a couple cycles ago to allow products like this to be utilized. And again, you see this will hold up to 200 pounds in the locking mechanism. Okay, so we had to have a change for the definition of receptacle to be able to use products like this. And it really makes it easy for the electrician to make those connections. So non-metallic outlet and device boxes. Today, most houses will be using non-metallic boxes. It's more economical. You can buy a whole carton of them. They're easy to nail up, and they're easy to move and move them around. If you didn't put it at the right height, you simply pry it off and relocate it in another location. But mainly it's the economics involved in it. House wiring systems usually formed by a number of specific circuits. Absolutely. So you'll learn in our program things like branch circuits, feeders, services, and you'll also learn things like small appliance branch circuits. You'll learn about laundry circuits, bathroom circuits. You'll learn their rating, their 20 amp rating, and what can be on them and what can't be on them. You'll learn all of those type of things. You'll even learn about home runs. And that's where I might take a 14-3, which has a black, a red, and a white, and we're sharing the neutral. Becomes what's called a multi-wire branch circuit out to maybe a certain area in the residence in order to maximize the amount of home runs that you have. All those type of things will be covered in this unit. You'll also learn about gang boxes. You'll have different things like 2 gang boxes, 3 gang boxes, 4 gang boxes, single gang boxes. You'll even learn about boxes that are designed as one big box, which you can segment down into multiple gangs. All of that type of stuff gets covered in Unit 2 of the residential system. Now it says multi-gang boxes used with more than one device is to be installed in one location. So that's called a multi-gang box. And it might have as much as 2, 3, or even 4 points in the box to be able to install devices. You have non-metallic multi-gang boxes. They're available in 2 gang, 3 gang, and 4 gang. They're marked with their cubic inch volume or with the number of conductors permitted in the box. Now this is interesting because if you have like an 18 cubic inch nail-up box, like we used to call them the old blues, but they come in gray and blue and in tan. They'll have varying degrees of cubic inch. Now, they'll either give you a cubic inch, and then you've got to go to 314.16 and look it up and do a little calculation. It's not difficult. We teach you how to do it in the program. Or it might tell you for some of those single nail-ups, it might tell you the number of conductors that go in it. It might say it allows 12, 14 conductors. And what we're going to do is teach you what a device takes up when it comes to conductor count, or what we call volume count. All that stuff that we're going to teach you in this program. So, again, it's a pretty extensive program. Mounting boxes, 314.20 states requirements for materials used to hold the back, retard, or slow down the spread of fire originating within a box. And it talks about closing things like gaps around the box and the depth in the wall and all this type of stuff. Again, closing the gaps around boxes reduces the ability for that fire to spread by allowing oxygen to be pulled through these gaps, kind of like a stack effect, and it really slows the spread. So you'll get all kinds of information on that. NEC 314.23b1, the mounting nails and screws through a box shall not be more than 1/4 of an inch from the backs or ends. This is boxes that maybe are metal boxes that have the holes in it, and you literally put the nails through it. And it'll show you how you position those nails towards, they can't be more than 1/4 of an inch from the back or ends of that metal box. And of course, all that's going to be covered in the program, and it's usually is covered by the manufacturer if the box happens to be listed. Damage control. One or more common problems electricians face is what happens to conductors in boxes during the construction stage of a job. Okay, so we will talk about that, where you put that box, how you put it, pushing those conductors all the way back into the box so that when the drywall or gypsum board finisher comes in a roto split or whatever they do, roto zip, that they don't damage your conductors. Okay, so again, the program will talk about that and give you some tips. Remodeling old work boxes. When installing new boxes in a finished wall, carefully locate the installation point after considering how the electrical wires will be fished or brought to the actual box itself. You might even have to use brackets that might hold a box, an old work box, into the wall. And basically the brackets go in the box, and then you have the little wings that wrap around it in order to hold it in place so it can't pull back out of the actual wall. And the brackets tend to look like this. And we'll cover all of this in the program. Now, the spread of fire. When you mount a box in a wall, it's important that we understand that we're not going to allow the spread of fire. Now, in a normal residential application, might not be that big a deal because most of the interior walls aren't rated. But when you're dealing with walls like the separation between a garage and the main structure of the dwelling, Or more importantly, what if I'm doing a multi-family dwelling where I'm treating all of these individual dwelling units, okay, as maybe a single family individual dwelling unit, but now I have a common corridor that's going to have a specific rating on it. So we have to be careful about certain things. But in residential, we also have to remember that we have to draft stop. We have to stop the spread of the potential fire. Okay, so that stuff's all covered in the National Electrical Code, and this program gets into more detail about that as well. So, spread of fire. Fire must be contained and not be allowed to spread to protect lives and property. NEC and other building codes must be followed. Conform to codes regarding the thickness of a wall, what types of gypsum board I have to install. Maybe it's a type X in the ceiling of a garage, and you got to be very careful what I put in there, because we don't want to lose the integrity of that barrier. Do not install electrical boxes back to back. And I'll show you. And this happens to do with if I've got a rated wall and I have to maintain a separation in that rated wall. So this might be something that comes in when I've got an apartment building and I'm doing the individual dwelling units, okay? But it has a common corridor where I have a rating on that wall from the separation. It's good to know this even when you're doing basic residential, because as you move up or you do something with more dwelling units in it, this can become a concern, and you have to be aware of that. Now, fire resistant ratings is basically when we give something a fire rating, we're actually saying it's the period of time the assembly will serve as a barrier to that spread of fire. So take this example here. Now, let's say in this wall, we're on this side of it, which is the bottom. This side of the wall has a 1 hour fire resistant rating. Okay, so since it has a 1 hour fire resistant rating, and I have this box that's in the wall, you see the spacing between the wood studs in the wall. Now, to meet the code, the electrical wall, the box is mounted on opposite sides of the wall, must be at least 24 inches apart. Okay, now notice the picture on the left. These boxes in the wall must not be mounted back to back. Why? Because that effectively puts a penetration in the wall. Means basically it's going from one side straight to the other. And we'll cover this in our program in detail, because you need to understand what the problem can be caused by this. Because if it was a 1 hour rated wall and you installed it like this, you have now broken down this ceiling or this 1 hour rating of this wall. Now, interesting, typically the stud spacing is 16 inches on center. So in this case, you see that a stud is going to separate and maintaining that 24 inches. And you'll notice that it's really not going to interfere with the integrity of the wall just by putting this receptacle in here on the left if I didn't put the one back to back, okay? All of this is covered in the building codes, but again, we talk about it in this program because it's important for you to understand it and learn it. Now, boxes for conduit wiring. Some local electrical ordinance require a metal raceway rather than a cable wiring. Now, this is very common in places like Chicago. Now, it's more economical to use a non-metallic wiring method like type NMB, which is a non-metallic sheath product. Okay, and it might be more economical to use something like an MC cable, metal clad, or even an AC cable. But there are some ordinances around the country, again, few and far between, that will require a metal raceway system. Well, we'll cover that as well. So when a metal raceway is installed in a residence, it is quite common to use 4-inch square boxes trimmed with a suitable plaster covering or a plaster ring because, again, you need the knockouts. The nail-up boxes are typically for cable assemblies, and they won't have the 1/2 inch or 3/4 inch or trade size 1/2 or trade size 3/4. They won't have the knockouts in it. So typically you end up using 4-inch square boxes to do this. Now, in this case, when I put those boxes in, or actually, be honest with you, when I put any box in a wall, whether it's in gypsum board or not, I have to worry about the gapping or how deep that box is in the wall. Now, think of this. You got to close the gap. Now, when you're an electrician, you put that box up, whether it's a 4-inch square or it's a nail-up box, you're relying on the drywaller who comes in and he's going to cut your openings. You're going to hope that your box is not going to be hidden, okay? But when they cut it in, if they create a gap around it, then you're going to have to do something about that gap. And that's your responsibility. Even though the drywaller or gypsum boarder, they might have done it to you. You have to maintain the integrity of that wall. So, like it says here, if I'm dealing with a non-combustible surface that are broken or incomplete around the box, employing a flush type cover or faceplate shall be repaired such that there is no gaps greater than 1/8 of an inch. Okay, so when we say flush, means that the receptacle and the outlet are all back in the wall, and I'm putting a faceplate or cover over it. Now, a flush type cover means that it's going to mount flush with the wall. Okay, whereas a surface mount means it mounts on the surface. On the surface of the wall. I get so excited. And so again, if it's non-combustible, then I can have a gap as long as it's not larger than 1/8 of an inch. If it's combustible, then I can't have any gap at all. Okay. Now, let's talk a little bit about what a yoke is, and you'll learn that more in our program. But a metal or polycarbonate mounting strap on which a wiring device or devices are attached. Now, think of a yoke or strap, a receptacle, the metal part that you mount to the box. That could be a polycarbonate, and I've seen that with some like a Cheetah Systems, which is I think a Leventon branded product. Or you have the devices, typically receptacles with the metal yokes, okay? Also referred to as a strap, okay? Now, I could have a single receptacle on it. I could have a duplex. I've even seen with a triplex on this again. So that is considered a yoke. Now, this is typically attached to the device box with number 6 32 screws, okay? So it's little thin screws, and you'll have that size is 6 with 32 threads. Okay, to the inch. Now, one yoke may have, again, 1, 2, or even 3 devices. Now, these devices will come most of the time, switches or receptacles, with that number 632 screw on it already. But you also have what's called special purpose outlets. Now, we say they're outlets again. So remember, we're not talking about receptacles specifically. Okay, these are called special purpose outlets. Now, usually they're going to be indicated on a drawing, have some unique symbol to let you know what they are, and the requirements may be that they're 240 volt circuits, a special grounding or polarized receptacle or other goes into it. Okay, so you'll have a special purpose outlet, and it will tell you what types of receptacles, or be honest with you, what type of device would go into it. Okay. Now, when you get into our program and you want to learn about the number of conductors that go into a box, it's going to take you to 314.16a, which gives information on the volume of metal boxes. And that talks about the maximum number of conductors of the same size that can be safely installed in a given type of box. Now remember, when you get into this program, that means that table is when they're all the same size conductors, okay, that go into that box. All right. Now, when they're not the same size, then you got to go to 314.16b. And that's going to give you what's called a volume allowance. And you can calculate out how much volume you have in that box. Remembering things like connectors that are inside of a box count as one volume. And that one volume would be the largest conductor in that box, okay, that's going through that connector. Maybe a receptacle's in there. That is what's called a double volume allowance. Okay, so if you were taking 14 gauge conductors over to the receptacle and their volume is 2 cubic inches, then a device receptacle would be 2 cubic inches times 2. So it's a double volume. It would count as 4 cubic inches. Okay, so that's the kind of the concept that you're dealing with in this layout. Now, selecting the correct size box depends on the mix of conductors and wiring devices, as I said, that are actually contained in that box. And we go over that when we're talking about 314.16a and 314.16b. In our residential program, we get in depth about it. Now, we also covered things like the depth of box, because there's minimum box depth that you have to be aware of in the National Electrical Code. And we go into that in the program. But you also have to make sure that your box is deep enough to put these devices in there. Okay, so the outlet and device boxes shall be deep enough so the conductors will not be damaged when installing the wiring into the box or into the device, into the box. You don't want to cram them in and it damage the conductors, okay? And of course, the width of the box must be obviously adequate to handle the device that you're putting into the actual outlet box or device box. Okay. Now, selecting the correct size box means that for connecting equipment grounding conductors to the box, a means shall be provided to in each metal box for the connection of an equipment grounding conductor. So if it's a metal box, it'll probably have location, a threaded point for a ground screw that will go in there. So you have to be able to make that connection. So you have to be able to take the equipment grounds and be able to connect them to the box via that equipment grounding conductor. Okay. Now, the means shall be permitted to be a tapped hole or equivalent. So they also make what's called ground clamps that will clip over the side of the metal box that will hold the equipment grounding conductors to the box. You're going to learn all about that in the program. Now, height of receptacle outlets. Electricians consult onto the plans and those specifications for mounting heights. That typically is going to tell you the height. But again, you have to remember that in the National Electrical Code, 210.52 is going to tell you that general purpose receptacles are going to be at a certain height, not above 5.5 feet. That doesn't mean you can't have them above that, but they might not count as the general use type of receptacles in your normal layout. But don't worry, either the plans will give you some ideas or you will just know it as you start to learn your placements, okay? But typically the heights recommendations might be 16 inches to center or 16 inches to the top for receptacles. That's from the finished floor. All those type of things are discussed in the program, but you'll get a kind of a flavor for how you like to do that. Just remember that you do have specific height limitations on some things. Doesn't mean you can't have extra receptacles up high, for example, behind the microwave or something to supply that microwave, but you're going to have limitations on height for receptacles, again, that are general use and they have to meet the layout requirements of 210.52. Again, all of that gets covered in the textbook. We show you some typical mounting heights and we even give you some recommendations. Okay. Lastly, today, we even talk about in the book positioning of receptacles. Now, there is no NEC rule for positioning. In other words, the ground plug, is that up? Is it down, to the left, or to the right? The National Electrical Code doesn't care. Now, what I will say is if you have metal faceplates, it's probably slightly safer to have the ground pin up so that if the metal plate falls off or the screw comes on loose, then it'll fall down onto the equipment grounding conductor terminal rather than come down and fall potentially on the hot and neutral and cause an arc. Okay, who knows if that arc has maybe combustible material laying against the attachment plug into the receptacle, and that arc causes some type of arc that causes a fire. Who knows? Okay, so there's some thoughts behind it, but as far as the National Electrical Code goes, doesn't really matter the positioning. Okay. Now, equipment grounding blades is the first to make and break. You'll notice that they are slightly longer than the neutral and the hot, so that it's the first to make and it's the last to break. Okay, so when you're making the connection and then pulling it out, those kind of concepts are really also part of things that are in NFPA 70E, the safety in the workplace standard. Again, this is something that's inherent to the attachment plugs and how they're designed. Okay, now the position of the equipment grounding conductor or grounding conductor slot on top does minimize the issue for metal plates, but there is no requirement. Now, you might have a local code that requires that in those multifamily dwellings or commercial buildings, but it really be any way you really want it. Some people in a bedroom, for example, if they switch a receptacle, they might turn that one receptacle with the ground up and all the other ones with it down so that at a glance, you know which receptacle is the one that's being switched. Again, that's something that you would learn over time and maybe you incorporate into your layout, but it's not a requirement anywhere. Now, face plates. Required to be installed so as to completely cover the wall opening and seat against the wall surface. You can have the receptacle that's in an outlet box that has that gap around it so that when you put the faceplate on, you actually can see around it into the gypsum wall. That's a no-no. So again, kind of a no-brainer. You're going to have to fill that gap. We need to have that faceplate flush with the system. Okay? All of those type of things are covered in this program in extensive detail. So, hopefully you got something out of this. This is kind of just an introduction into the residential program. This is just chapter 2. These are not all of the details that we go into in the chapter 2. It gets really in depth in box fill and all those things. But remember, there's a lot of units in the residential program, and we literally will walk you through every single room in a dwelling so that you know how to tackle everything like bathrooms and the GFCI requirements and the kitchen requirements. All of that stuff is walked through in this program. So I'm excited about it. Hopefully you will too. And if you have any more questions about our residential program, go on and email us at info at masterthenec.com, and we'd be more than happy to answer those questions. Or go to our website, masterthenec.com, and go to the Contact Us page, and you can send notice to us there. So until next time, folks, stay safe, and God bless.
Shut up and sit down.